Arc fault circuit interrupters, often called arc fault breakers, are designed to protect against electrical fires caused by arcing faults. A common issue encountered is nuisance tripping, where the breaker trips even with minimal load. It is indeed a common occurrence for insulated staples, if driven too tightly, to cause arc fault breakers to trip. Arc fault breakers are incredibly sensitive to electrical noise and disturbances. When a staple is driven too tightly, it can inadvertently create a small short circuit or an arc. This arc is then detected by the breaker, which then causes it to trip, effectively cutting off the power to the circuit as a safety measure. Inspectors usually require arc fault breakers to be tested before walls are covered to ensure proper functionality. Testing can be performed in a few ways. Firstly, pushing the test button on the breaker itself simulates an arc fault and should cause the breaker to trip immediately. This is a basic functionality test. Secondly, connecting a load to the circuit. A small load, such as a radio or a lamp, can be connected to the circuit to test its behavior. If the arc fault breaker is functioning correctly, it should allow the load to operate normally without tripping. If it trips, that indicates a potential issue. When troubleshooting arc fault breaker issues, several areas should be investigated. Firstly, ensure proper neutral wiring. Arc fault breakers rely heavily on the neutral wire to detect imbalances in current. It's crucial to verify that the neutral wire is properly connected at all termination points and is not overloaded. Overloading the neutral can create imbalances that the arc fault breaker interprets as a fault. Secondly, check for damaged cables. Conduct a thorough inspection of the wiring in the circuit, looking for any signs of damage or nicks. Even small damages to the insulation can create opportunities for arcing. Thirdly, tighten electrical terminals. Loose connections are a common cause of arcing and can easily trigger the breaker. Ensure that all electrical terminals within the circuit, including those at outlets, switches, and the breaker itself, are properly tightened to the correct torque specifications. Fourthly, use high-quality staples. Some cheaper staples may not be insulated adequately, which increases the risk of arcing, especially when they are driven in too tightly. Use only high-quality, insulated staples that are specifically designed and rated for electrical work. These staples provide better insulation and are less likely to cause arcing. Fifthly, contact the manufacturer. If the breaker continues to trip after you have exhausted all troubleshooting steps, it is prudent to contact the manufacturer directly. They can offer technical support and potentially provide a warranty replacement if the breaker is found to be defective. Here's additional advice for the inspector encountering this problem. It's important to systematically test and verify each component of the electrical circuit. Test the arc fault breakers with a load connected to the circuit, as this provides a real-world scenario for the breaker to function under. Inspect the wiring meticulously for any signs of damage or loose connections, paying close attention to areas where staples have been used or where wires may be bent or strained. Ensure that the neutral wire is properly connected and not overloaded, as imbalances here can easily cause nuisance tripping. Use only high-quality, insulated staples for all electrical work, and ensure that they are not driven in too tightly. Driving staples too tightly can compromise their insulation and create opportunities for arcing. If the problem persists after these steps, contact the manufacturer for further assistance, as there may be an issue with the breaker itself. Here's a breakdown of how arc fault circuit interrupters work. Arc fault circuit interrupters, or arc fault breakers, are advanced safety devices designed to protect electrical circuits from fires caused by arcing faults. These faults can occur when damaged, worn, or improperly installed electrical wiring creates unintended electrical discharges. Unlike standard circuit breakers, which primarily protect against overloads and short circuits, arc fault breakers are designed to detect and respond to specific arcing signatures. The detection mechanism within an arc fault breaker is highly sophisticated. It relies on advanced electronics and algorithms to differentiate between normal electrical signals and the distinct patterns associated with arcing faults. There are two primary types of arcing faults that these breakers are designed to detect. Firstly, series arcs. Series arcs occur when a wire is broken or has a loose connection, interrupting the flow of current in the circuit. This interruption creates a localized arc as the electricity jumps across the gap. Secondly, parallel arcs. Parallel arcs occur between two conductors that have compromised insulation, allowing electricity to flow where it shouldn't. This can happen between a hot wire and a neutral wire, or between a hot wire and the ground. Arc fault breakers use specialized sensors to monitor the electrical waveform and frequency for irregularities that indicate the presence of an arc. These sensors can detect rapid fluctuations in current and voltage, as well as high-frequency noise that is characteristic of arcing. When an arc fault is detected, the breaker trips, cutting off the power to the affected circuit and preventing the arc from escalating into a fire. There are different types of arc fault breakers designed for various applications. Firstly, branch or feeder arc fault circuit interrupters. These breakers protect the entire branch circuit from the breaker panel to the first outlet. They are typically installed in the breaker panel and provide comprehensive protection. Secondly, outlet circuit arc fault circuit interrupters. These are installed at the outlet and protect the wiring downstream from that point. They are useful for protecting specific areas or appliances. Thirdly, combination arc fault circuit interrupters. Combination arc fault breakers provide both branch or feeder and outlet circuit protection in a single device. They are the most common type and offer the highest level of protection. The National Electrical Code, often referred to as the NEC, has specific requirements for the installation of arc fault breakers to ensure electrical safety in residential and commercial buildings. The NEC mandates arc fault protection in various areas of the home, including bedrooms, living rooms, dining rooms, and other living spaces. These requirements are updated periodically to reflect advancements in technology and safety standards. When troubleshooting arc fault breakers, it is important to follow a systematic approach to identify the root cause of the problem. Firstly, visually inspect all wiring and connections in the circuit, looking for signs of damage, loose connections, or improper installation. Secondly, use a multimeter to test the continuity of the wiring and check for any shorts or ground faults. Thirdly, try isolating different sections of the circuit to narrow down the location of the fault. Fourthly, test the arc fault breaker itself to ensure that it is functioning properly. This can be done by using the test button on the breaker. If the breaker trips when the test button is pressed, it indicates that the breaker is likely working correctly. If the breaker does not trip, it may need to be replaced. Here are some best practices for working with arc fault breakers. Firstly, always turn off the power to the circuit before working on any electrical components. Secondly, use properly insulated tools and equipment to prevent electrical shock. Thirdly, follow the manufacturer's instructions for installing and testing arc fault breakers. Fourthly, never bypass or disable an arc fault breaker. They are critical safety devices that protect against electrical fires. Fifthly, if you are unsure about any aspect of working with arc fault breakers, consult a qualified electrician. They can provide expert guidance and ensure that the electrical system is safe and compliant with all applicable codes and regulations. By understanding how arc fault breakers work and following best practices for installation and troubleshooting, you can help prevent electrical fires and ensure the safety of your home or building. When dealing with nuisance tripping, consider these additional points. Firstly, appliance compatibility. Some appliances, especially those with older motors or electronic components, can generate electrical noise that arc fault breakers may misinterpret as an arc. Try unplugging appliances one at a time to see if one is causing the issue. Secondly, dimmer switches. Certain types of dimmer switches, particularly older models, can also create electrical noise that interferes with arc fault breakers. Try replacing the dimmer switch with a standard switch to see if that resolves the problem. Thirdly, LED lighting. Some LED bulbs and fixtures can cause issues with arc fault breakers due to their switching power supplies. Try using different brands or types of LED lighting to see if the tripping stops. Fourthly, shared neutrals. Sharing a neutral wire between multiple circuits can sometimes cause imbalances that trigger arc fault breakers. Make sure that each circuit has its own dedicated neutral wire. Fifthly, moisture. Moisture in electrical boxes or wiring can create leakage current that arc fault breakers detect as an arc. Inspect for any signs of moisture and take steps to dry out the area. Sixthly, conduit fill. Overfilling electrical conduit can damage wire insulation and lead to arcing. Ensure that the conduit is not overfilled and that the wires are properly protected. Seventhly, harmonics. Harmonic distortion on the electrical system can cause issues with arc fault breakers. This is more common in commercial or industrial settings where there are many electronic devices. An electrician can use specialized equipment to measure harmonic distortion and recommend solutions. Eighthly, surge protectors. Certain surge protectors can create leakage current that arc fault breakers may interpret as an arc. Try unplugging surge protectors to see if that stops the tripping. Ninthly, temporary power. If temporary power is being used during construction or remodeling, it may not be properly grounded, which can cause issues with arc fault breakers. Ensure that the temporary power setup is properly grounded and meets all applicable codes. Tenthly, ambient temperature. Extreme temperatures can affect the performance of arc fault breakers. Make sure that the breaker is installed in an area where the temperature is within the manufacturer's specified range. 11thly, electrical storms. Electrical storms and power surges can sometimes damage arc fault breakers, causing them to trip more frequently. After a storm, it's a good idea to test the breakers to make sure they are still functioning properly. 12thly, physical damage. Inspect the arc fault breaker for any signs of physical damage, such as cracks, dents, or discoloration. If the breaker is damaged, it should be replaced immediately. 13thly, improper grounding. Inadequate grounding can cause voltage imbalances and increase the risk of arcing. Ensure that the grounding system is properly installed and maintained. 14thly, wire gauge. Using the incorrect wire gauge can overload the circuit and increase the risk of arcing. Make sure that the wire gauge is appropriate for the circuit's amperage rating. 15thly, load balancing. Unbalanced loads on a multi-wire branch circuit can cause excessive current flow in the neutral wire, which can trigger arc fault breakers. Distribute the loads evenly across the different phases. 16thly, check for backfed circuits. Backfed circuits can create dangerous conditions and cause arc fault breakers to trip. Make sure that all circuits are properly wired and protected. 17thly, consider professional testing. If you have exhausted all other troubleshooting steps and the arc fault breaker continues to trip, consider hiring a qualified electrician to perform a comprehensive electrical inspection and testing. They have the tools and expertise to identify and resolve complex electrical issues. Remember, electrical safety is paramount. If you are uncomfortable working with electrical systems, always consult a qualified electrician. Here are some specific scenarios where nuisance tripping is commonly reported. Firstly, older homes. Older homes with outdated wiring systems may be more prone to nuisance tripping. The wiring may have deteriorated over time, leading to insulation damage and increased risk of arcing. Secondly, homes near industrial areas. Homes located near industrial areas may be subject to voltage fluctuations and electrical noise from nearby machinery. This can interfere with the operation of arc fault breakers and cause them to trip unnecessarily. Thirdly, homes with solar panels. Solar panel systems can sometimes create harmonic distortion in the electrical system, which can cause issues with arc fault breakers. Fourthly, homes with electric vehicle chargers. Electric vehicle chargers can draw a significant amount of current, which can overload the circuit and cause the arc fault breaker to trip. Fifthly, homes with swimming pools or spas. Swimming pools and spas often have complex electrical systems with multiple pumps, heaters, and lights. These systems can be prone to ground faults and other electrical issues that can trigger arc fault breakers. When dealing with these scenarios, it is important to have a thorough understanding of the electrical system and the potential sources of interference. Consider these additional safety measures. Firstly, install surge protection devices. Surge protection devices can help protect electrical equipment from voltage spikes and surges, which can damage arc fault breakers and other sensitive components. Secondly, use ground fault circuit interrupters, often referred to as GFCI outlets, in areas where there is a risk of moisture, such as bathrooms, kitchens, and outdoor locations. GFCI outlets can detect ground faults and quickly cut off the power to prevent electrical shock. Thirdly, regularly inspect and maintain the electrical system. Schedule regular electrical inspections to identify and address any potential problems before they become hazards. Fourthly, educate occupants about electrical safety. Teach occupants about the dangers of electrical shock and fire and how to use electrical equipment safely. Fifthly, create an emergency plan. Develop an emergency plan in case of an electrical fire or other electrical emergency. The plan should include procedures for evacuating the building and contacting emergency services. Remember that electrical systems should always be handled with care and respect. By following these safety measures, you can help prevent electrical accidents and ensure the safety of your home or building. When it comes to selecting arc fault breakers, consider these factors. Firstly, amperage rating. Choose an arc fault breaker with the appropriate amperage rating for the circuit. The amperage rating should match the wire gauge and the expected load in the circuit. Secondly, type of protection. Select an arc fault breaker that provides the type of protection needed for the application. Combination arc fault breakers offer the most comprehensive protection, but branch or feeder or outlet circuit arc fault breakers may be suitable for certain situations. Thirdly, manufacturer reputation. Choose an arc fault breaker from a reputable manufacturer with a proven track record of quality and reliability. Research different brands and read reviews to make an informed decision. Fourthly, compliance with standards. Make sure that the arc fault breaker complies with all applicable standards and certifications, such as UL listing. This ensures that the breaker has been tested and meets safety requirements. Fifthly, ease of installation. Choose an arc fault breaker that is easy to install and wire. Look for features such as clear labeling and easy-to-use terminals. Sixthly, availability of support. Select a manufacturer that offers good technical support and customer service. This can be helpful if you have any questions or problems during installation or troubleshooting. Seventhly, cost. Compare the prices of different arc fault breakers and choose one that fits your budget. However, don't sacrifice quality for price. It's important to choose a reliable breaker that will provide adequate protection. Eighthly, warranty. Check the warranty offered by the manufacturer. A longer warranty indicates that the manufacturer has confidence in the quality and durability of the breaker. Ninthly, local codes and regulations. Be sure to comply with all local codes and regulations when selecting and installing arc fault breakers. These codes may specify certain requirements for arc fault protection in certain areas or applications. Tenthly, future needs. Consider any future electrical needs when selecting an arc fault breaker. If you plan to add more circuits or appliances in the future, you may want to choose a breaker with a higher amperage rating or more advanced features. 11thly, feedback from other electricians. Talk to other electricians and ask for their recommendations. They may have experience with different brands and models of arc fault breakers and can provide valuable insights. 12thly, consider the environment. Consider the environment where the arc fault breaker will be installed. If it will be exposed to moisture or extreme temperatures, choose a breaker that is designed for those conditions. 13thly, think about the load type. Think about the type of load that the arc fault breaker will be protecting. Some loads, such as motors or electronic devices, may require special types of arc fault protection. 14thly, check the breaker's interrupting rating. The interrupting rating is the maximum amount of current that the breaker can safely interrupt in the event of a short circuit. Make sure that the interrupting rating is sufficient for the electrical system. By considering these factors, you can choose an arc fault breaker that is appropriate for your needs and will provide reliable protection against electrical fires. Finally, here is some advice on how to prevent future issues with arc fault breakers. Firstly, use proper wiring techniques. Follow proper wiring techniques when installing or modifying electrical circuits. This includes using the correct wire gauge, making secure connections, and protecting wires from damage. Secondly, avoid overloading circuits. Avoid overloading electrical circuits by plugging too many appliances or devices into a single circuit. This can cause the circuit to overheat and increase the risk of arcing. Thirdly, keep electrical equipment clean and dry. Keep electrical equipment clean and dry to prevent corrosion and other problems that can lead to arcing. Fourthly, regularly inspect electrical cords and plugs. Regularly inspect electrical cords and plugs for signs of damage, such as fraying, cracking, or loose connections. Replace any damaged cords or plugs immediately. Fifthly, don't run electrical cords under rugs or furniture. Don't run electrical cords under rugs or furniture, as this can damage the insulation and increase the risk of arcing. Sixthly, use surge protectors. Use surge protectors to protect electrical equipment from voltage spikes and surges. Seventhly, hire a qualified electrician. Hire a qualified electrician to perform electrical work and inspections. An electrician can identify and address potential problems before they become hazards. Eighthly, follow manufacturer's instructions. Follow the manufacturer's instructions for installing, operating, and maintaining electrical equipment. Ninthly, be aware of electrical safety hazards. Be aware of electrical safety hazards and take steps to protect yourself and others from electrical shock and fire. Tenthly, educate others about electrical safety. Educate others about electrical safety and encourage them to follow safe practices. By following these tips, you can help prevent future issues with arc fault breakers and ensure the safety of your electrical system. Electrical safety is an ongoing process, and it requires attention to detail and a commitment to following safe practices.